Hello, everyone. Today I am presenting my year-long professional development plan for elementary probability. Probability is a critical part of mathematical literacy because it helps students interpret uncertainty, analyze risk, and make informed decisions. However, it is also one of the most challenging topics for both students and teachers because it requires reasoning about variability rather than fixed answers. Research shows that probability is often underdeveloped at the elementary level, even though frameworks like the Gaze report emphasize its importance across all grades. Many teachers lack confidence, rely on procedures, and struggle to address misconceptions. For example, students often believe outcomes should even out in the short term, which reflects intuitive but incorrect reasoning. The purpose of this professional development is to help teachers build conceptual understanding, move beyond procedures, and use hands-on data-driven instruction. Ultimately, the goal is to help students develop deeper probabilistic thinking through meaningful learning experiences. The plan begins with a needs assessment survey that measures teacher confidence, understanding of probability concepts, and instructional practices. This ensures the professional development is tailored to actual teacher needs, which research shows is essential for effectiveness. The main goals are for teachers to understand probability conceptually, address misconceptions, design inquiry-based lessons, and integrate probability with data analysis. Instruction emphasizes reasoning, discussion, and exploration rather than memorization. This is a year-long professional development plan because sustained learning is more effective than one-time workshops. Each session includes hands-on experiences, discussion, reflection, and classroom application. This progression builds from intuitive thinking to formal reasoning. In September, the teachers complete a needs assessment and engage in prediction tasks like repeated coin toss scenarios to uncover misconceptions about randomness and independence. In October, teachers explore sample space using hands-on materials like colored counters, learning to systematically identify all possible outcomes and use precise probability language. In November, through coin toss experiments, teachers collect data and observe how small samples vary, helping them understand variability and long-term patterns. In December, teachers design and test spinners with unequal sections, connecting visual models to probability and exploring fairness in outcomes. In January, using 2 dice, teachers investigate sums and discover that outcomes are not equally likely, leading to an understanding of combinations and frequency. In February, teachers compare theoretical probability with experimental results, analyzing why outcomes may differ and how larger samples improve accuracy. In March, digital simulations allow teachers to run large trials quickly, helping them visualize patterns and better understand probability distributions. In April, teachers design their own probability lessons, incorporating hands-on activities, discussion, and strategies to address misconceptions. In May, teachers analyze student work and share lessons, identifying patterns in student thinking and refining instruction collaboratively. In June, the teachers reflect on their growth, complete a post-survey, and identify strategies they will continue using in their classrooms. Teachers engage in hands-on experiments, data collection, visual models, and digital simulations. These strategies help students connect short-term variability with long-term patterns and develop deeper understanding. A key focus is supporting all learners, especially multilingual learners. Strategies include visual supports, structured discussion, and sentence frames like I think blank is more likely because blank. The PD is evaluated using pre- and post surveys, lesson plans, and student work samples, and teacher reflection. This ensures the learning leads to meaningful changes in both teaching and student outcomes. In conclusion, this professional development plan addresses a major gap in elementary mathematics instruction. By focusing on conceptual understanding, hands-on learning, and sustained support, teachers will be better prepared to help students understand probability, interpret data, and make informed decisions. Thank you for taking the time to listen to my presentation on elementary level probability.